Hello and welcome to our first class. Today we are going to understand the foundational concepts that guide the introduction to programming with a bias towards engineering programs. So at the end of this particular lesson, my expectation is that we should be in a position to identify what you would actually refer to a computer with respect to a given mechatronic system. You should be in a position to explain what a program is. You should be in a position to describe what we mean by the term programming. You should be in a position to apply the input process output model with any given system that is available to you. And at the end of the day, you should be able to create or to construct just a simple control logic. To begin with, a computer is an electronic device. And in this particular case, we are going to be looking at an electronic device as an example of like a water level controller. Now, that electronic device normally receives inputs. Once it receives the inputs, it processes those particular inputs according to certain instructions that have already been provided, and it produces a given set of an output. So I want us to look at this particular automatic water system or a water control system, and I want us to have a look at a few things. We are having a water level controller which has been placed at this particular point. This water level controller, it's supposed to receive signals from these water level sensors that have been placed inside that particular tank. Now, once it receives the signals, this particular signals that it receives is the one that it's actually going to push downwards to the water pump, and it's going to inform whether this water pump ought to be switched on or switched off. And so when we are talking of an electronic device, you can imagine that this water level controller is undertaking an activity on the basis of certain inputs that it has received. So it received the signals from the water level sensors, and it was able to process them depending on what readings were captured, and an output was given, which in this particular case is the pump either being switched on or switched off. So our controller will only work on the basis of the instruction that has been fed into it. So I want us to move forward and get to understand what we mean by a program. Let's ask ourselves, looking at this particular water level controller, if we are to remove this, whatever logic, whatever instruction that is actually switching the water pump on or off, if it's removed from this water level controller, the question then is, would our pump automatically switch on or off? And the answer is no. So there is an instruction that has actually been fed that is determining when the pump comes on or when the pump goes off. And that set of an instruction is going to look something like this. That if the water levels are below certain threshold, which for example is our low mark which we have put, then we are supposed to turn the pump on. In other words, the pump is supposed to start. If our water pump is above a certain threshold, the uppermost limit, then we are supposed to turn the pump off. Now, these sets of instruction is what is actually enabling our pump to either come on or come off. And this is what we are referring to as a program. So we can define the computer program as a sequence of instructions. You can see these instructions have been written in a certain manner. So it's a sequence of instructions that are written, that are supposed to perform a specific task. The task here is to either turn the pump on or pump off. In other words, we can also refer to it as a set of ordered instructions. Now, when you talk of ordered, it means that there is a manner in which they are supposed to be written. You can't begin with turning the pump on and then you test whether the water levels is below a certain threshold. So it's a set of ordered instructions, and they tell, in this particular case, is a water level controller, what to do. So whether should it turn our pump on or our pump off. The next thing that I want us to understand is what we refer to as programming. Now, before this controller was actually manufactured, a few things happened. One, someone must have thought through how that controller ought to operate, and it was supposed to help control or to manage water levels within a particular tank, when it's high or when it's low. Then those particular thoughts that were there were translated into a certain set of instructions, which later we are going to refer to them as a code. So someone translated that logic or that design logic into a certain set of instructions which look like this, and then someone tested it. And so when the water went below certain threshold, did the pump go on? When the waters rose to a certain high level, did the pump go off? So when that was tested, it was seen, then it was installed into the controller, and then thereafter the whole system was released into the market. So programming is the process or the art of writing these particular instructions in a manner that our machine, which in this given case is our water level controller, can be able to understand and influence how it behaves. So these particular instructions are the ones that are actually going to be pushed into this water level controller, and they are going to control how it behaves in this particular case. When does it trigger the pump to go on? When does it trigger the pump to go off? The other definition that is critical for us to understand is the programming language. What does it mean? We are going to realize that our controller here does not understand our natural English, the one we normally use for our communication. And therefore, there is need to use a language that this particular hardware device can be in a position to understand. And that's what we refer to as now the programming language. How do we write in a language that that particular controller or the computer understands? So a programming language is just but a formal set of instructions, which is what we are going to be learning in this particular unit. So there's a formal set of instructions, syntax and rules that are used to communicate with a computer and direct its behavior. So in a natural language, you would have written something of this nature, but we are going to see that when we now want that particular activity to be undertaken here, there is a manner in which we have now to translate this in a language that our given water level controller understands, and so that it's able to behave in a certain manner. And so the responsibility of the other case is what referred to as a programmer. So a programmer is the person who actually wrote the logic that is actually performing this particular task. So that's the person we're actually going to refer to as a programmer. So this person was able to write the logic that will be responsible for capturing the sensor readings, determining what action ought to be taken based on those sensor readings, and then triggering whether the pump should go on or should go off. So in a nutshell, a programmer is a person who writes programs using a given programming language. That is what we would refer to as a programmer. We switch gears a little bit, and now we look at the three parts of any operation that a computer normally undertakes. We have said that every activity that is done by a computer is normally in three phases. So we normally have the inputs, we normally have the process, and we normally have the output. And so any program will always or generally perform those three roles. So the inputs is responsible for receiving data, and this data could actually be coming from a user. Maybe you may type from a keyboard, or it may actually be coming from a trigger by your mouse, and so on and so forth, or it could actually be coming from a particular device. In this particular case, our input is actually coming from the sensors that have been put inside that particular tank. Now, the water level sensors, they are the ones that are actually going to detect the water height. And once they detect the water height, they are going to send signals back to the controller, and the signals that they're actually going to be sending are for either the high level readings or the middle level readings or the low level readings. Without these particular signals or without these particular inputs being pushed to a water level controller, then we may not be in a position to control when this particular pump ought to come on or off. Number two, once these inputs have actually been fed into the controller, we go into the next stage, which we refer to as the processing. Now, processing is where calculations is actually undertaken, or manipulation is actually undertaken, or translation of those particular inputs into certain outputs. So the processing is actually going to happen in the water level controller. And the processing happens on the basis of what? Remember, there are instructions that we have pushed inside our controller that the pump should be turned on when our water level is less than the low mark that has actually been provided for. And then the pump should be turned off if the water levels go beyond the high mark that has actually been pushed. And so the sensors that we are having here are responsible for sending those readings, the low mark, the middle level mark, and the high mark. And it's on the basis of that, and that the processing is actually going to trigger that if the low level was actually sent, then the pump is going to be turned on. If it's a high level that was actually sent, it means that we have actually gone beyond the required threshold, then the pump is actually going to be turned off. Now, this decision is actually being undertaken in the processing stage, is what is actually being responsible for picking the inputs and doing certain sorts of computation, and then doing or giving us rather a certain output. The last bit is what referred to as the output. Output is responsible for displaying or saving the results of the processing stage that has actually been undertaken. In respect to our water pump motor, we are going to see that the controller, once it has determined whether the levels are below or the levels are high, there's a trigger that is actually going to be sent to our pump to either switch off the pump or switch on the pump. So, and our output, we are actually going to see our pump is actually off or our pump is actually on. So that is the three stage that normally happens. We normally have inputs, and those particular inputs are the ones that are processed within our particular controller, and we are able to see certain results. As we come to an end, there is need for us to understand that we normally have different sets of programming languages. And the reason as to why we normally have different sets of programming languages is because of the different disciplines that we normally have and the nature of the problems that exist in the different disciplines. When you look at in the engineering domains, you are going to realize that we may require languages that are able to interface with hardware, languages that are able to provide instructions to a given hardware so that it's supposed to perform in a certain way. But in the business environment, you may find that the big task that we want is computation for certain sets of input values that are actually coming in. We may not be interfacing with a given hardware. So depending on the environment we are working with, the domain of application, we have different sorts of languages that are well suited for that. And so in our engineering course, we are going to be using C as a language, which has actually been found very useful in the programming of different hardware devices. So I would wish to stop at that given point, assuming that we have been in a position to understand each of those particular concepts. Go through this video again, trying to ensure that you can be able to identify a computer. You can explain what is a program, what is programming, programming language, programmer, and so on and so forth, that you can be in a position to apply an input process output model, not only for this particular system, but in the event you are provided with another system. Can you as well also be able to explain what are the inputs, what will be the process, and what will be the output. Thank you, and I look forward to seeing you